All right, welcome to 5.6. I'll let you use the slider to tell me how you're doing today. And if you want to say any more, you can. We are going to be graphing linear inequalities in two variables. This is actually Chapter 5, Section 6. Today's date is today. We're going to be checking solutions, graphing them, and doing a word problem. So, the difference between a linear line and a linear inequality. The linear inequality is shaded. Anything that is shaded is a solution. You might want to hit pause and read that on your own. I'm going to actually cross off a couple of the steps here. Step 2, I'm going to show you a different way of doing this. When we graph the boundary line for inequality, you're going to use a dashed line like this for a less than or an equal sign. You're going to use a solid line like that for less than or equal to, greater than or equal to. So if it's got the equal sign with it, solid. And if it is going to be a less than, equal to, or less than, you're going to end up shading below or underneath. If it's a greater than or equal to, or greater than, you're going to shade above. Oops, it should be an O. So shade above or on top of. Okay? And you're going to see some examples in a few minutes. So on this one, we want to graph an ordered pair that is a solution. So what that means is anything that is in the shaded region is a solution. So all of these points that I'm shading are a solution. Yes. When we did this in class, I had some people putting dots on the line. Whoops, let's do that in red. I had people doing dots on the line. That's actually a no, because that's a dotted line. So the line is not part of the solution. If it were solid and had that equal sign with it, then it's part of the solution. So anything that is outside of the shaded region or on a dotted line is not part of the solution. So here in green, graph an ordered pair that is a solution. This is solid, so this one actually could be on the line, or it could be anywhere in the shaded region. And red, that is not. So anything outside of the shaded region is not. So notice that the T is exposed. Explain why. It's not part of the solution. So if you do not have a graph, describe a second method. You can plug x and y into the inequality. If you get a true statement, it is a solution. A false statement, it is not a solution. So on this one, we want to determine whether or not it is a solution. If you are a typer and you want to type out your solution, you can do it right here. That square root sign will let you type math symbols. So on number 1, I'm just going to plug my x and my y in. So 2, I'm sorry, that's a negative 2, plus 2, greater than 0. You end up getting 0 is greater than 0. Now 0 is equal to 0. We don't have an equal sign there, so that one is a no. On number 2, again, I'm going to plug my x and y in. 4 times 0 minus 0 is greater than or equal to 5. Simplify that, you get 0 is greater than or equal to 5. Well, 0 is not bigger than 5, so that one is a no. Number 3, plug in my x and my y. 5 times negative 4 minus 2 times negative 1 is less than or equal to negative 1. That's going to give me negative 20 plus 2. Be careful with negative numbers here, because you get negative 18 is less than negative 1. Yeah, that actually is smaller. Okay, so that one is yes. And number 4, plug in my x and y. Negative 2 times 5 minus 3 times negative 7 is less than 15. You get negative 10 plus 21 is less than 15. Add those together and you get 11. 11 is less than 15. So that one is yes. All right, now we're going to go ahead and graph this. I'm going to first solve for y, so I'm going to add x to both sides. And that's going to give me 2y is greater than x plus 2. Divide each term by 2, because we're trying to get that y by itself. Y is greater than 1/2, and I'm just separating the x and the 1/2 out. All right, my y-intercept is 1, so I'm going to put a dot at 1. My slope is 1/2, so up 1, right 2. Up 1, right 2. And that there's no equal sign, so this needs to be a dotted line. And that is a greater than, so that means bigger. So I need to shade above the line. And I am not good at shading on the computer, so imagine that this is all colored in. And that's what it should look like. If you want to, you can go to desmos.com, open up a separate tab, and go to the graphing calculator and type that equation in exactly as it looks, and it'll graph it for you. So I'm going to do a couple of these. On the first one, y is greater than negative 1. That would be a horizontal line that's dotted. And I would shade above. The next one, right here, number 2, x is less than negative 4. Well, that's going to be a vertical line, and it's going to be solid. Imagine that that is a straight. And it is less than, so you have to shade everything that's smaller. So you would do that. On number 3, I would subtract x from both sides. And that's going to give me y is less than or equal to negative x minus 4. So my y-intercept is negative 4. My slope is -1, so I'm going to go down 1, right 1, and that's going to be a solid line. And that was a less than, so I'm going to shade underneath the line. All right. I will let you do the last one on your own. All right, on this one, you're going to spend $10 on grapes, which I'm going to call X, and apples for Y. You can spend at most $10, so I can spend $10 or less. Grapes cost $2.50 a pound, and apples cost $1 per pound. So there is my inequality. I'm not going to type it out again. You can do that on your own. Write and graph an inequality that represents the amount of grapes and apples you can buy. Identify two solutions. So on this one, I'm actually just going to go to desmos.com, open a separate tab, open the graphing calculator, and type it in exactly as it looks, 2.5x. I'm going to get the less than or equal to, type the keyboard. Oops, I forgot my y. Plus y. And that has to be less than 10. So there is my graph right there. And then it asked us to interpret some results. Well, I do want to talk about a few of those results. First of all, I can't have any negative, and this was grapes for my y, or my x, I'm sorry, and apples was my y. I can't have negative grapes or negative apples, so the only part of the graph that is actually feasible is this part right here that I'm shading. Okay? That's the only part that is feasible. Then anything in there is something I could buy. So if I wanted to, I could have bought 4 pounds of grapes and no apples. Or I could have bought, at 0, 10 pounds of apples. Or, right here, that ordered pair, which is 1, 3, 1 pound of grapes, 3 pounds of apples. I would not have spent my whole $10, but that would have been fine. All right. That is everything I have today. I'll let you do your final reflection, how you feel about everything, and enjoy.